Welcome to our very first unit preview. If you are accessing this video, you are either a physics teacher or you're a leader that is supporting physics. Either way, you're welcome. This video will walk you through the teaching and learning highlights of the unit. Let's begin. My name is Garrett Dyer, and I'm the physics and engineering teacher from Uplift Peak. I will also serve as the physics content teacher leader for the year, and I'm very excited to work with you this year. And that's a picture of me and my two kids. Here we have stage one. Let's start with the statement of inquiry. Change is constant because everything is interconnected. This SOI speaks to me because I tend to look at the world through a scientific lens naturally. In that aspect, this world is always changing. However, this SOI is broad enough that you can apply its statement to many other areas of life other than science. I feel like that will be important for our scholars. Their world at their age is so small, and part of our major push in the MYP is for our scholars to start seeing themselves as a connected and productive member of the human race that stretches all the way across the globe. Now, looking at the global context, I chose globalization and sustainability. The main reason I chose this context for our first unit in motion was because globalization in general is dependent upon the interconnectedness of communities, societies, governments, and nations. Motion is fundamental to the act of globalization. Physics can tie in easily with this context in many ways. For example, you could frame the global context into a kinematics problem dealing with the international trade, where scholars have to analyze the motion of a cargo ship that's delivering freight from Cape Town, South Africa to New York. The combinations of what you can do here are seemingly limitless. Up next is my key concept, change. As a physics teacher, we all know that even when motion is constant, there is still change occurring. When an object is at rest, it may be motionless in that frame of reference, but it is still moving in a different frame of reference. Which takes us back to this concept that change is constant. Since our first unit focuses on the unidimensional translation of objects, then it seemed very natural for me to choose change as our first key concept. My two related concepts are form and movement. Again, these seemed like natural choices to make for this first unit when selecting these for connecting to the SOI for our day-to-day lessons. Both the movement of an object and the form of an object's motion influence how a change in motion occurs. We see this when studying how celestial objects move through the universe, or even how a baseball moves through the air when it's thrown. Again, the idea here was to choose these concepts that broadly connect to the unit. Those connections can be utilized by teachers in the classroom to inspire different avenues of critical thinking through the global context lens. Ideally, scholars will start to do this on their own more so throughout the year. Here are the inquiry questions. Looking first at the debatable questions. I really like these because they dig right into the SOI. These are easy questions to ask, but have the potential to lead to some really interesting discussions depending on how they're framed in the classroom. They're broad enough to apply to much more than just science-based topics. Therefore, these questions can offer flexibility in how you ask scholars to critically think beyond just physics-related concepts or scenarios. Question 3 is great for globalization and sustainability, which is our global context for the unit. Both the economy and the environment could be avenues for discussion here as you go through your lessons. For example, you could have a physics scenario over the Delaware-sized iceberg that recently broke off of its ice shelf in Antarctica and ask a question about its displacement over time. Then follow that up with, can a change locally have effects globally? The first two debatable questions can really feed each other, or they can stand alone. So again, depending on how they're asked in your classroom could spark some interesting discussions. The conceptual questions were inspired by the debatable questions. The meaning of change itself naturally carries a dimension of time. Therefore, it is easy to repurpose the debatable question, is change constant, into a conceptualized question for physics, since all we study in this unit is dimensions of motion that are changing. Therefore, the answer to the second conceptual question, why do we use time when referring to different aspects of motion, could be constructed around how change has a dimension of time, and we are studying dimensions of motion that are changing from one value to another, so we need time to reference that change in motion. We as teachers want our scholars to critically think in our classrooms, and we as teachers want them to learn how to voice their educated opinions and views. I believe these questions could be used as a resource to help energize that reality in the classroom. Here we have the TEKS for this unit. The only two content-specific TEKS we cover in Unit 1 is 4A, generating and interpreting motion graphs, and 4B, describe and analyze motion using the kinematic equations. These are straightforward and will drive the unit content. To the right are the knowledge and skills associated with this unit. Since this is a big unit, I've made two lists of what scholars are expected to know from this unit. You'll notice the lists are separated according to priority. The low-frequency list is important for scholars to understand. However, the unit-specific knowledge is what will be the main focus. Lastly, the skills list is meant to provide you with the most important skills that scholars need to take away from this unit. Mastery of these skills will ensure scholars are successfully set up for Unit 2. Next up, we have the vocabulary list. When I made the list initially, it was much longer. However, I took out some words and made the list more manageable by also categorizing the vocabulary into a priority list and a low-frequency list. They are all important terms for physics, however. I want the teachers that need some guidance on which words are non-negotiable for this unit to have a list that clearly states what vocabulary to primarily focus on. One word on the priority list that all teachers need to focus on right out of the gate is magnitude. Scholars see this word throughout the course in many different problems, and I have found in my years of teaching that if you do not stress to your scholars to learn the meaning of this word, then it becomes an unnecessary barrier to scholar progress throughout the year. At the bottom of the page you can see the interdisciplinary connections. I chose to make a connection through our SOI to individuals and societies. Since the scholars in physics will be taking U.S. history for their humanities course this year, then I wanted to make an intentional connection to their content in that class. Both I and the 11th grade humanities teacher at Peak will frame questions in class that pinpoint the SOI. Change is constant because everything is interconnected. I'm excited for scholars to experience this SOI-inspired dialogue in other classes than just my own, because it helps them to start adopting the reality that the world is not as compartmentalized as some of them may think. Hopefully, they will even look at their own classes and see their interconnectedness through the lens of the SOI. Now that we've reached Stage 2, let's go over the performance assessment for this unit. I wanted the scholars to complete a task that has a focus on critical thinking, so I decided to utilize an online PhET simulation which can be found by Googling PhET, that's P-H-E-T, Moving Man, or simply by going to PhET, P-H-E-T, .colorado.edu and navigating to the physics simulations and selecting Moving Man. What scholars will be doing on the content side of this unit is that they will be assessed through all three strands of Criterion A to be able to explain, apply, and evaluate motion graph data. They will need to use the simulation as a tool to help them accomplish this task. The assessment uses the GRASPS framework to structure the task for the scholars. You can see there are some real-world references made in the role, audience, and situation portions of the assessment. These help scholars to open up to the idea that what they are doing in class is a simpler model of what is really happening with the content they're learning out in the real world every day. The product part of the assessment is going to be what what the scholars will actually produce out of this task. There will be 3 sections to the task. Section 1 of the task will have them use the Motion Man simulation to produce displacement, velocity, and acceleration time graphs. They will then have to explain the moving man's motion by creating a story that coincides with the events shown in the graphs. Next, Section 2 will have scholars apply the content of this unit thus far, namely evaluating and interpreting motion graph data in various kinematic problems. These problems will be set up in such a way that they can utilize the moving man simulation to help them discover the solutions to those problems. Lastly, there will be an analysis question. It will ask scholars to analyze and evaluate motion graph data to make scientifically supported judgments. Again, the focus behind this task is to inspire that critical thinking component. Now that I've gone over how the content relates to the performance task, I want to talk a little bit about how the statement of inquiry relates. As scholars use the moving man simulation, they will be observing how the kinematic variables, displacement, velocity, and acceleration are constantly changing. They will also have the opportunity to visualize how each variable is interconnected to the next. This is fundamental for physics, since velocity is a rate of an object's change in position against time, and acceleration is a rate of that object's change in velocity against time. But even if we break away from the content side of how the SOI applies, then we still are asking scholars to look at the world through this idea that it is constantly changing, because everything in the world is somehow connected to everything else. There is no perfectly isolated system on this planet or in this universe. However, since we are connecting the SOI to the task, then we can speak to the SOI through the lens of the physics content. We need to use the SOI to help scholars see that when a change in an object's position occurs, then the velocity and the acceleration of that object reflects that change accordingly. Additionally, there is nothing on this planet that is at absolute rest. What looks motionless, like a rock laying on the ground to an observer, in that frame of reference, is still moving rotationally because it's part of this planet. Therefore, we really do mean that change is constant when we look at the SOI and speak to this unit's content through it. We as teachers, during not only in this part of the unit, but in all parts of the unit, want to push scholar critical thinking through this SOI lens. Here we have the evaluative criteria for this unit's performance assessment. I took the MYP Criterion A and mentioned some task-specific clarifiers on the right side. Now we have reached stage 3 in the unit plan preview. I have been mentioning critical thinking in the previous slides pretty consistently because it is not only what we should be pushing every day for our scholars, but for this unit specifically, critical thinking is one of our approaches to learning. I want scholars to understand what inquiry is. I believe inquiry is the key to helping our scholars grow as critical thinkers, as functioning and productive members of society, and it teaches them a system of how to investigate. I have listed some ways that I will be using critical thinking in my lessons. These are broad statements that can really apply to every unit we teach. I would like this unit to be the frontline push for this kind of classroom thinking all year long. Secondly, we have collaboration as our other ATO. As teachers, we know the importance of collaboration. Inquiry is a process that is best practiced around other colleagues. I want my scholar in my classes to see each other as colleagues and not just students in the same class. I want them to discover each other's strengths in my class and leverage those strengths with each other in their group work so that they can grow and learn for themselves. On the right side, you will notice the learning experiences and teaching strategies. These stand as the mile markers for this unit. I wanted you to have a list that could connect the skills and understanding of this unit in Stage 1 to the day-to-day planning here in Stage 3. In this slide, we've moved down in the unit plan to differentiation. Here, I really wanted to give some practical things to look out for based on learner levels. The way that I separated the two lists was based on the two TEKS we teach under for this unit. Motion graphs is for TEKS 4A and kinematics formulas is for TEKS 4B. Be on the lookout for scholars exhibiting these markers in class. This will help you to disaggregate the learner levels in your classroom early on so that you can start to offer differentiated environments based on your own scholar-learner level population. The formative assessment box is to help you see different mediums through which scholar learning will be formatively assessed. The real-world connections section is to provide a broad avenue for connecting scholars to real-world thinking in light of the information in this unit. This section really goes well with the Stage 1 information, like the SOI, the global contexts, and key concepts, to help draw that connection out beyond just the classroom. This is a good box to look at as you plan out CFUs and other possible SOI-connected debatable questions. The resource list is there to specify some of the resources that are important for the classroom progress of this unit. Take special note of the Vernier lab equipment. All of this year's required core labs for physics will be utilizing Vernier equipment. Please see your campus administrator if you need to order equipment for these labs. You may also reach out to me at any time by email if you need a specific list of materials to order. Now we have finally come to the backwards planning portion of this unit. The first 2 days in physics are set aside to serve as a math review. Every year, my scholars need this. In actuality, many need more time to review math than just 2 class periods. Therefore, I usually ask scholars to see me about setting tutoring time so that I can extend my review with them. Notice how the objectives are dual-coded. I have incorporated this feature into all of my lesson objectives for this year. This is analogous to the ways that scholars are assessed in STAR. Even though physics doesn't have STAR, I still feel like dual-coded objectives better support the push towards inquiry in the classroom. The objectives in physics many times will have scholars first analyze or describe a situation, data table or graph, and then apply their findings to come up with a solution for a different scenario. All of the regular lessons will be taught through a 5-step structured inquiry variant, where learners will engage in questions provided by me or some other source. Then they will be given data and told how to analyze that data. From there, scholars will be provided with evidence in order to formulate their own explanations. Scholars will then connect those explanations to the unit-specific knowledge, and then they're given steps on how to communicate and justify their explanations. This is also how the ATLs will be satisfied for the unit. The inquiry questions from Stage 1 should also be woven in as scholars are building and justifying their knowledge and physics explanations in the classroom. Here is the first official physics lesson planned for the new school year. Notice the dual-coded objective with key points in the middle. I added the debatable questions from Stage 1 because I wanted to see if my scholars' answers to these questions change over time throughout the course of this unit. Another feature that I'm implementing this year is storytelling. Some of you teachers out there are really good at telling relatable and entertaining stories for your scholars extemporaneously. However, I am not. I have to plan mine out. I haven't done this before, but I have thought about it. This year I'm doing it. I'm creating a series of short stories that follow specific characters around through their daily lives. My goal is to use the storytelling to build suspense for my class and to get scholars to look forward to attending my class the next time. Additionally, I want to use the events in the stories to connect to a physics problem or scenario. I have included the first two short stories in days 3 and 4 of the unit plan as exit tickets. However, I will continue the stories day to day as part of my guided practice or independent practice as well. I encourage you to take the stories if you'd like or start your own. Whatever you decide to try, just make sure that learning is fun in your class. That will help scholars look at their class with a sense of ownership. This is the last part of the exit ticket from the lesson I was just showing. Here we see how the objective is assessed in connection with the story. The last thing I would like to point out is that Day 6 is the planned day for Core Lab 1, Card on a Ramp. I made an investigatory annotated model lesson specifically over this lab. Please feel free to find it on Blackboard and reference it as you plan for your core lab. Also, you can see that the performance assessment is planned to take place after the core lab, and I reserve 2 class sessions for it. This is a time that you will want to draw connections to the SOI as much as possible because that is the underlying theme to your whole unit. These days here in the unit represent real-world applications or scenarios that connect back to the knowledge and skills of the unit. But be looking for ways to push outside of that content bubble and extrapolate connections out to other areas of life, knowledge, and skill. It never hurts to sit and brainstorm some extra CFUs in light of the SOI and global context for any unit you teach that you can consistently ask during your day-to-day lessons. This marks the end of our virtual unit plan preview for Unit 1. If you have any more questions, feel free to email me or call me. I hope you've enjoyed previewing Unit 1 and that it's been helpful. Thank you. Have a great day.